Okay, so welcome back to part 2 of the video on LM311 where I'm going to just help you solve review question 14.1 and help you understand what this circuit does for you. So by now you should know that this is the symbol for a thermistor. It's a negative NTC thermistor. This is a buzzer. So more or less, you should be able to figure out that this is a temperature sensor. And when the temperature either goes too high, too low, whatever it is, the buzzer will buzz. Okay, so let's understand first of all, which one is my reference voltage. So it seems that they have fixed this fella because this one is not changing. Okay, it is fixed. Uh, the output to this voltage divider is going into my non-inverting, and therefore this is my reference voltage. So that's the thing you first have to recognize, that this is my reference voltage. Okay, so let's find out what my reference voltage is. If you use a voltage divider method, you'll find that the reference voltage is equals to 2.5 volts. So this fella is fixed at 2.5 volts. Let's write that down here. 2.5 volts. Okay. Then let's look at the inverting terminal. So this is my thermistor, it's an NTC thermistor, and you should know that the NTC thermistor, if I plot the resistance against the temperature, the graph will look like this. Okay, so let's find out what happens when there is a very low temperature. When the temperature is very low, the resistance is very high. Okay, so I've got a very high resistance across the thermistor. That means the voltage across this fella will be very high, and therefore the voltage across R1 will be very low. Okay, because this fella takes most of the voltage, leaving very little energy, the voltage for R1. So therefore, when the temperature is very cold, when it is cold, V in negative, this pin 3, the inverting terminal, will be very low. Okay, can? So I'm going to assume that it is so low, it's going to dip below the reference voltage. Okay, it's going to go low and lower than 2.5 volts, the Vref. Yeah. So if this is low and the non-inverting is high, what this means is that the V out goes high. Yes, V out goes high. So this will be a 5 volts. Now, this end is also 5 volts. If this is 5 volts and this is 5 volts, there's not going to be any potential difference across the buzzer, and therefore the buzzer will not buzz because there's no potential difference across it. Okay, can? So let's take a look at what happens when it is very hot. Yeah, so maybe let's change the color of the pen to red. So what happens when it is hot? Okay, when I have a high temperature, the resistance across the thermistor is very low. So this now has very low resistance, therefore it'll take a very little voltage across it, and most of the voltage will be left for R1. So if there's a high voltage here, therefore the signal going into my inverting will be a high voltage. Okay, so the V in minus will now have a high voltage. Now I'm going to assume that it goes higher than the 2.5 reference voltage. Yeah, so if this the inverting is now higher than the non-inverting, this fella will now go low. The output will go low. I'm going to assume that it's low 0 volts. Yeah, so now my V out will be a low. And now, since the other end of the buzzer is 5 volts and this end is 0 volts, there's going to be a big potential difference of 5 volts. Current is going to flow, and therefore the buzzer will buzz. Okay, therefore buzzer will buzz because there is PD, potential difference of 5 volts across it. Okay, Ken? So it basically, how this circuit works is that when the temperature goes high, the buzzer will buzz. Now, how high? I don't know. So this is where you have to calibrate your reference voltage. In fact, I wouldn't put two fixed resistors here. I will put a trim pot here, a variable resistor, so I can calibrate what is my reference voltage. So in this case, I can decide at what temperature will the buzzer buzz. Yeah, so this one needs a little bit of calibration. No one really would put a two fixed resistors here, because then there will be no way to calibrate. Yeah, we want to calibrate it so because each working environment is different. Yeah, so I hope you understand how LM311 works. It's a very useful tool to help us make decisions based on the surroundings, and we use this a lot in our projects. Yeah, so if you have any questions, please look for me, or you can email me and I'll try my best to answer them. Okay, if not, this will be the end of the lecture on LM311. See you.